I continue with lecture 18. Of MET 303. Here we proceed to find integration of this, and for that integration of 0 to 5 x sin n plus 1x dx. And therefore this is equal to minus 1 upon 2 0 to 5. So we split it into the two parts. This is s minus s formula. So it is 2 times cos sine. And due to that it is 1 by 2. Clear? Now we apply integration by parts. U and this is V. 1 by 2 cos n plus 1x upon n plus 1 minus sin 0 to 5 minus integration 0 to 5 plus minus sin see here how it is. X u as it is. Integration of sine is minus cos. N plus 1 is coefficient, so we divide it. Actually there is a sign of minus, but integration of sine is minus cos, and therefore though it becomes plus, differentiation of x with respect to x is 1, and therefore it is not in any calculation right now. Minus 1 by 2. The same here. X integration is minus cos. Actually there is sign of minus. Differentiation of x with respect to x is 1. Minus minus becomes plus. And therefore this is not in calculation. But right now, whenever we integrate this term, the next term will be sine. On for sine, it is 0 and it is at 5 and at 0 at 0. Again here integration is sine. It is 0 at 5, it is 0 at 0. And therefore, this term is not in calculation. So we have to deal with only this part. And therefore, this is equal to 1 by 2 minus pi cos n plus 1 pi upon n plus 1. At 0 this value is 0. Plus pi cos n minus 1 pi. If it is the second term, it is minus minus twice. And 1 by 2, that is outside of bracket. This is equal to pi by 2 cos n pi minus pi upon n minus 1 minus cos n pi plus pi upon n plus 1. So it is pi by 2 cos n pi upon n plus 1 minus cos n pi upon n minus 1. So this is equal to pi by 2 cos n pi n minus 1 minus n plus 1 upon n square minus 1. So this is equal to pi cos n pi upon 1 minus n square. So obviously n greater than 1, because at n equal to 1 it is equal to 0. So we have to find the values for n equal to 1 separately. Therefore, for n equal to 1, x sin x cos x dx 1 by 2x sin 2x dx. Here again u equal to x, v equal to sin 2x. Now see here, whenever we put pi, it is pi by 2 and cos 2 pi will be 1. But whenever we put 0, it is 0 in multiplication, and therefore this term will not be in calculation. Furthermore, integration of cos 2x, this is not there. Cos 2x will be sin 2x, and therefore it is 0 at pi, it is 0 at 0, and therefore this will not be in further calculation. So we have to deal with only this term. So answer is minus pi by 4. So this is only value we have to consider whenever we calculate A1. For A0, we have to find it separately, and that is 2. A1 is minus pi by 4, and this is values. These are the values for n greater than 1. But the value which we have find in equation 1 is n equal to 2 upon pi, because equation 1 implies that pi cos n pi upon 1 minus n square. So pi will be cancelled, and therefore this is equal to 2 cos n phi upon 1 minus n square. This is the value which we will require in future. Let's start our calculation furthermore, but few moments you have to solve. So by Fourier series expansion, we have fx equal to approximately equal to 1 by 2 a0 plus sigma an cos nx and running from 1 to infinity. So it is 1 by 2 a0, a1 cos x, a2 cos 2x, a3 cos 3x, a4 cos 4x plus a5 cos 5x and other terms. So we have value of a0 is 2. You can find that. We have calculated. So few minutes back you can find the value of a0 and it is 2. So it is 1. 1 by 2 into 2, so it is 1. a1 is minus pi by 4. Just I calculated. Minus pi by 4 cos x. Value of a2, see, this is value of an. Cos n pi minus 1 raised to n. N is 2. So it is 2 upon 1 minus 2, 1 plus 2. So it is plus so value of cos 2 pi will be 1 or minus 1 square will be 1. So it is 2 upon 1 minus 2, 1 plus 2 into cos 2x. Sorry, cos 2x plus then value of n equal to 3. So it is 2 minus 1 cube upon 1 minus 3, 1 plus 3 into cos. So here, whenever we take n equal to 4, it is 2 minus 1 raised to 4, 1 minus 4, 1 plus 4 cos 4x. Then we take n equal to 5, so 2 minus 1 raised to 5, 1 minus 5, 1 plus 5 cos 5x and other terms. So this is equal to x sin x equal to 1 plus 2 1 minus pi by 4 2 times. Okay. We have to multiply this is value of a1, but we have to divide it by 5. So it is minus pi 1 by 4 cos x minus 1 upon 1 into 3 cos 2x plus 1 upon 2 into 4 cos 3x minus 1 upon 3 into 5 cos 4x plus 1 upon 4 into 6 cos 5x and other terms. See here, we have to multiply this, divide this by pi because this is value of a1 but without pi, and therefore we have to add pi there. So it is 1 plus minus 1 by pi by 4, and then we are taking 2 in common, 2 upon pi minus 1 by 4 then minus 1 by 1 into 3 cos 2x. All these things by this formula. and therefore therefore if we put x equal to pi by 2, if we put x equal to pi by 2, it will become sin pi by 2 will be 1, and therefore pi by 2 equal to pi by 2 equal to 1 plus 2 . This is 0. This is minus 1. This is 0. This is plus 1. This is 0. Then it is plus 1. So the values are 1 upon 1 into 3 minus 1 upon into 3 into 5 and other terms. So this is value of pi by 2. If we divide both these side by 2, therefore value of pi by 4 is 1 by 2 plus 1 by 1 into 3 minus 1 upon 3 into 5 and other terms. So this is pi by 4 expansion by the formula of x sin x. Now read the statement of example 11. Here we want to find Fourier series expansion of x plus x square. And check that if you consider this sum as two sums as x and x square. So fx equal to x, this is sum number 7. And fx equal to x square is sum number 8. And this is summation of both. If you find, I have already done the sum number 11. And if you find the solution there from my note or from anywhere, you will find that it is just a sum of two sums. Now I leave this portion for you to enjoyment of Fourier series sums. And with that, I start with theorem number 12, and it is also known as Bessel's inequality. It is also known as Bessel's inequality. As we are going further in our syllabus, you will understand that what I want to say, and you will understand it clearly. If you are doing lots of writing practice, then it will be very easy for you. As any mathematician can do, you can do. So for that, we have to understand the concept of Riemann integration. We have to consider the concept of convergence. And the statement of theorem 12 is, if f is Riemann integrable minus pi to plus pi, then this series sigma an square plus bn square converges. Convergence means it will be convergent, and where an and bn both are Fourier coefficients. And as you know, what is Fourier coefficients? I don't want to take proof of this theorem right now, but I will continue the same theorem in the next one. But you have to understand the concept of Riemann integration. Whenever you learn Riemann integration, you have to consider all the concept of Riemann integration, why we are using this here. But as of now, if you consider Riemann integration, because I know that you have not reached up to the Riemann integration, because it will be in your syllabus from the second term. So you have to consider this as a integrable function. So what is integrable? That you know very well. So I stop my lecture here and continue in the next lecture. Thank you very much.